Guys, welcome back to another video, and in this video we're going to be continuing on with our SwiftUI tutorial series, and in this particular tutorial we are going to be taking a look at list in SwiftUI. Now there are a few ways to create a list in SwiftUI, and I'm going to show you those ways in this video. Now we first need to talk about what exactly is a list. Well, a list is a single column of data that you can show pretty much anything in. You can show weather data. You can show you can show character stats. You can show information about a project or a task in a project management application. You can use a list as a sidebar, stuff like that. It's very, very useful, and it's a very fundamental control. So you're going to have to really understand how this works. All right? So let's get started by first talking about what we need as a prerequisite to work with a list. And that is, we need some kind of data source, some kind of source of data. At least if you want it to be dynamic. If you don't need it to be dynamic, like you want to construct a sidebar list and you only have a few screens, then you don't have to do anything special. You could just have your list, and then inside of that list have some navigation links in there and all that kind of stuff. Make it kind of static rather than something that is dynamic. All right. So I have some data in a constants file. All this is it's an array of objects of type device. Now, device conforms to identifiable, and that's important later. The structure has a let constant for ID, where that gets set to a new UUID every single time an object is created, so they always get a unique identifier. Then we have a device name, so the name property is a string. And then we have another string property called device symbol. Now this is the symbol in SF symbols for the given device. My data here, my source of data is pretty much all the different iPhone models, iPad models, and Mac models available for purchase right now at the time of recording this video. So like 15 Pro Max, 15 Pro, iPad Pro, 13-inch, 11-inch, that kind of stuff. That kind of stuff is in this data set. All right, so in your in a navigation stack or inside of the body of your content view, we're going to create our list and say, okay, let's go into Xcode, and we'll say capital LIST, and then open up some parentheses, and then give it your data. So constants dot devices, and then we have our opening curly brace for our closure. This closure takes in an argument, which is going to be the current object being iterated over in the list. So we'll call this device in And then inside of our list, we'll say device cell. This device cell is a custom view that's simply just an H stack that has an image for an SF symbol, and then there's a text view for the name of the device. That's all this view is. This takes in a device object, so we'll pass it device like that. We can save this and run it. Okay, so I still have the run destination set to my iPad. I'm going to set this to my Mac here. All right. Let it run and kind of do its thing. All right, so here is, here's the app. You can see we have a list, and we have all of our symbols as well as the names for the devices. Perfect. That's exactly what we wanted to happen here. Now, one thing I need to note about this way of using list is that the objects in the random access collection that you pass in, so in this case it's an array, the objects in there have to conform to identifiable. So if your object, like device or something, does not conform to identifiable, you cannot put you can't put that random access collection in there. The alternative is to use a for each. So if I go into Xcode here, and I go into content view, so what we'll do is we'll get rid of our closure argument here, and then we'll get rid of this set of parentheses altogether. So we just have list, and it's taking a closure for the content of the list. Now we're going to get an error because we're not getting any device objects. So we can fix this by, inside of our list, using a for each structure. This will loop through the array or random access collection that you give it, and then it will do whatever you need it to do. In this case, return a view for every iteration through the collection. So we'll say capital F for capital E each. We can pass it our random access collection. So device or devices constants dot devices, and then we can have our closure for our for each, because this takes in a closure. We'll give it device in like that, and then close that off. If we save this and run it, we get a successful build, and there is our list of devices. However, we still run into the same problem that we had before. This version of the for each initializer requires that, again, all the objects in the random access collection that we're giving it conform to identifiable. And so that's why we're getting successful builds here, is because device conforms to identifiable. But what if it doesn't? Well, if it doesn't, you need to provide some other hashable value that it can use to identify the current iteration. Notice how I said hashable, right? So the ID that we give it as a second parameter, that we give for each as a second parameter, has to be a key path to some value that conforms to hashable. So let's say we didn't have an ID and device did not conform to identifiable. Well, string conforms to identifiable. And generally speaking, the device name is going to be unique. So we can point to the name of the device as its identifier. Let's go ahead and add that parameter now. So we can do a comma, ID, \, name. All right, so let's go ahead and save this and run it. And there it goes. So everything is now working exactly as intended. And now we don't need our object to conform to identifiable. If you want to use the hash for the object that conforms to hashable, all you need to do is append .self to the end of that. So that way it uses the hash for the name rather than the name itself as an identifier. And if we run this again, and we replace this, we get the exact same result again. All right. So that is how we can create a list in SwiftUI. There are many different ways, like I said. It just depends on your scenario. It highly depends on the context of what you're building, on which approach you're going to use. Now, with this video having come to a close, I want to give you a challenge. Now, this challenge it involves accessibility. All right? So, if you're unfamiliar with how to use VoiceOver on the Mac, on iOS, or whatever device you're using, the first step is to read up on some of the documentation for VoiceOver, some of the support articles for how to use it. You can even go into settings and do a training to learn how to use it. I have a video on the channel teaching you how to use VoiceOver on iOS. That video also applies to iPadOS. When you're done with that, once you have a grasp of VoiceOver, I want you to look at the documentation for 3 different modifiers. All 3 of these modifiers are accessibility modifiers. All right. The first one is accessibility label. Look over the accessibility label documentation so you understand what that does. Second, I want you to look at the accessibility disabled modifier. This modifier will remove a view from the accessibility tree, or not, well, not accessibility disabled, I'm sorry, accessibility hidden. The accessibility hidden modifier, that's the second one. The third modifier that I want you to look at is the accessibility element modifier. So look at those three modifiers in the Apple developer documentation. And using that knowledge, I want you to solve this problem. So right now with our list cell, we hear the name of the symbol as well as the text for the name of the device when navigating our list with VoiceOver on macOS and iOS. On macOS, the cell itself is treated as its own accessibility element, but reads both accessibility elements within it. On iOS, each individual accessibility element in each cell is focusable, but the cell itself is not treated as an accessibility element. So what I want you to do is to make sure that on all platforms, the cell in the list itself is treated as an accessibility element. And 2, I want you to make sure that you do not hear the name of the symbol. I want that to be hidden from the accessibility tree. And we only want to hear the name of the device. That's it. All right, so that's your challenge. That pretty much does it for this video. Thank you all so very much for watching, and we'll see you in the next one.